Okay, during the next 20 school days, we're going to be doing what's called qualitative analysis, or identification of unknowns. I call it the CSI of chemistry. Each of you will be getting a vial like this that contains your unknown compound. And this is an ionic substance, which means it contains a positive ion and a negative ion, kind of like salt is sodium chloride. Your job is to identify the positive and negative ion. Each of you will work individually. It's a laboratory scenario where you work all year this way. There are 7 tests that you're going to do with each one of these, and you're going to use the 7 tests to determine what your compound is. The ions that make up the compounds are 15 positives and 13 negatives. We're going to do a sample unknown, in particular this one, to try to identify it, which means this unknown contains one of these positive ions and also one of these negative ions. They make that ionic compound. So we'll go ahead and do the 7 tests and see how this turns out. You'll be asked to use the data table, which will be given to you like this, and we'll record the information on that. You'll also have a booklet of which you'll have the information about each of the particular ions, which lists the behaviors of all these ions. So we'll go ahead and start with the first test. And the first test is called the inspection test. And as I hold this up, if you can zoom in on this, we can see this has a pale violet color. And this means that this is a colored compound. And this is a significant clue. For as we look at this, we go over to our table here. Of the 15 positive ions, there's only 5 that are colored, namely iron, chromium, copper, cobalt, and nickel. And the fact that this is a colored compound tells us we must have one of these 5 ions. So that's a significant clue. As we look at this also, we can see it's moist and crystal formation. So that's part of the inspection test, and I'll give you a moment to jot this down. Second test that we're doing is called the inspection and acid test, or the solubility and acid test. And what we'll do is we're going to get a sample of the unknown. I want you to zoom in on the amount that we're getting here. It's a very small amount. And we'll add that to a test tube. And what we're going to do is to add some distilled water to this. And we want to dissolve it. And we'll go ahead and mix this up. And this is how you do that. Just hold that between your forefinger and your thumb, squeeze on it, and then just start hitting it like this, hitting it back and forth like that. And that creates a little whirlwind in there to get it to dissolve fairly quickly. Okay, so we have a solution of our unknown. What we then want to do is to test with litmus paper, and we have both blue and red. So I'll take the piece of blue litmus paper and just tilt it in and put your paper in there so that it covers the solution. And it looks like the blue litmus turns a little bit red. And the red litmus stays red, which indicates this is slightly acidic. I'll give you a moment to jot this down on your data table. Okay, the third test is called the flame test. And what we do is to take the solution that you made to dissolve your unknown first. We're going to get a splint that has been soaked in distilled water. And what we'll do is to soak this in the solution and also put it in the sample of your unknown to get some dry on there. Now this one is crystal, won't stick to it much. So before we get this going, we want to get the Bunsen burner going. So in lighting that, make sure you light the match first, then turn the gas on. Okay, we have our stick that's been inserted in the solution of the unknown and our dry unknown, and we'll put it in the flame. And what we're looking for is a color other than pale yellow. You can see there's a pale yellow there, not much happening. Okay, and we can try this. You can do this test over and over. and I'll try it again just to see with just liquid on there and see if anything happens. Because sometimes just the liquid alone will give us a flame color. Again, nothing happens with that, and I'll try it again and just stick it right in there to see if any crystals stick to that, and we'll insert it in again. We can see there's no characteristic flame other than a pale yellow. I'll give you a moment to jot that down. For the fourth test, it's called the ignition test. And what we'll do again is get a sample of our unknown, put the bottom of a dry test tube, and it does need to be dry, and we'll put the clamp on there and we'll go ahead and start heating this. And we're going to try to ignite it, and basically we heat this to see if it's going to melt, which this easily does. And we continue to heat to see if a colored gas is produced. And we can see within the test tube a brownish gas is produced, if you can see this in the background. And so that's a very good clue that we'll jot down. So go ahead and jot this down on your data table. I'll give you a moment to do that. For the fifth test, you're going to need a dry test tube and a small sample of your unknown. This test is called the dilute sulfuric acid test. Put a sample into a dry test tube. What you'll then do is add 5 drops of dilute sulfuric acid. And we look for bubbling to occur as we're adding the acid. That did not happen here. So what we next do is to go see if we can get a reaction happening with heating. And what we're looking for in here is the production of a colored gas. So as we go to heat this, we look inside the test tube. You can't tell by the gas coming out, but inside the test tube, if a colored gas other than white is being produced, and we can see that nothing actually happens on this test. And I'll give you a moment to jot that down on your data table. On the sixth test, again, we'll take a sample of our unknown, put in the bottom of a dry test tube. Now this time we're going to use concentrated sulfuric acid. And this is by far and away the strongest acid that we'll be using. So as always, you'll wear your safety goggles every time you walk into the lab and make sure that your eyes are covered. Okay, we're going to go ahead and add our concentrated sulfuric acid, again up to 5 drops, and we're going to watch and see if any bubbling occurs as we add these drops. And again, no bubbling is observed here. So we'll go ahead and heat as directed, looking for the production of a colored gas to see if that occurs. And looks like we do get a brownish gas produced in this particular one. So that is another significant clue. Heat it just a little bit more. Yep, so we saw the brown gas produced. So that is a really good sign. I'll give you a moment to jot that down in your data table. As we look at our data table, it looks as if, and I'll just go hold this up, you have a copy of this. We've done 6 tests. We've got an idea on our positive ion. We're down to 4 possible ions. We've eliminated copper because it does have a characteristic flame. These others do not. So we can take copper out of the equation. On the negative ion, we don't have a clue. So this is where I suggest you do what's called creative browsing. You go through your booklet, and I'll have you turn to page 7 in particular, and we'll read what it says about nitrate. As it says on the preliminary test, concentrated sulfuric acid reacts with nitrates to produce a yellow-brown gas. Dilute sulfuric acid usually does not produce a colored gas. That's how our unknown behaved with the con and dilute acid test. So we suspect nitrate. So the logical thing to do would be to test for the nitrate ion. As we read further, we'll go down and see it says there's a good test for nitrate, which says to do the brown ring test. And so what I'll do is we'll go ahead and do this. But it says here, it should be pointed out that similar results can be gotten with nitrite and bromine. But there are other differences which will allow you to identify these ions. So if you do the brown ring test and it does not work out, negative on nitrate, so it means you would test for nitrite and bromine. Well, to do the brown ring test, what we do is to take an unknown, again, and go ahead and take a small sample, and we'll dissolve this in water. Now I have the sample here already, so we have our nitrate, or our unknown, dissolved in water. And what we want to do is to add a 1/4 scooper. Now I have the iron 2, as it says, this is ferrous sulfate, which is iron 2 sulfate, so it'll be in this container. We want to take, it says a 1/4 scooper, so what that looks like, if we'll get a zoom in on that, looks about just like that. Okay, so we'll add that to our unknown and shake it up. And it says in the directions there, if a precipitate does not form, go on to step 3 below. So we take this out, check this out, and it's dissolved completely and there is no precipitate. So we go to step 3. It says take the tube and add it to a beaker, of which we'll set it sideways, and add up to 10 drops of concentrated sulfuric acid. So what I'm going to do is go ahead and add this in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to hold this up because what we have here is forming a brown ring. If you can zoom in on that, this ring is forming right along the bottom here. If I look inside, I don't see anything because it's a ring that's going around. I'll hold this straight up and down. Can we get a good picture of that? So that's what you look for, and this proves that the nitrate ion is present. So I'll give you a moment to jot this down on your data table. The 6th and final test is called the sodium hydroxide test. And with this test, again, we take a sample of our unknown, small amount, add it to a test tube. We're going to add distilled water. Fingers width is what we always use. Beat it up a little bit, make sure it's all dissolved. That's very important on this test, because if it's sitting at the bottom here and we add hydroxide, there's not enough in the solution to make a reaction happen. So what we're looking for here is the formation of a precipitate. And if the precipitate stays or goes away with additional drops. So we'll go ahead and follow that process. Here it's completely dissolved. Go ahead and add our sodium hydroxide. I'll add the first drop. We do get a precipitate forming. We see a color change there. Now I want to see if that precipitate stays or goes away. It's getting darker. There's 3, 4, 5. It's getting darker yet. 6, 7, 8, 9, and 10. We do get a brownish jelly-like precipitate forming here. So what we want to do is go ahead and record this in our data table. Now afterwards, since we're talking about the hydroxide test with the iron, and we are down to these 4 ions that we think we might have for our positive ion. So it would be logical to see if iron, cobalt, nickel, and chromium add sodium hydroxide to these. And so what we have here are 4 test tubes, and they're labeled so we can see the colors of these now. And what we'll do is we'll go ahead and add sodium hydroxide to these to see if it reacts like our unknown did. So I'll go ahead and take the sodium hydroxide and add it to each one. because ours has to match one of these. Okay, so here's our unknown. Here are the 3 of the 4. Which one do you think matches? I'll give you a moment to jot this down on your data table. What we've done so far is narrow down, we think we have iron. So these are now out. We need to do what's called a confirmatory test. So if you look on page 3, we'll go down the line and see if our compound fits the description. Iron compounds are colored and produce no characteristic flame. It's pale violet, no characteristic flame. Hydroxide ions form a colored precipitate. We do have a colored precipitate with hydroxide, so that fits. Hexanoferrate ions react with iron 3 to produce a colored precipitate. We don't know what that color is, so logic says we ought to get a known iron compound, dissolve it in water, add hexanoferrate 2 to it, and see what that precipitate looks like. So I have a known iron compound, and we'll add some hexanoferrate, and we can see we get a deep blue precipitate. So this is a known iron compound. So what I want to do is to take my unknown, which I have here, and add some hexanoferrate to it and see if it matches. And we can see, here's a known iron, here's my unknown hexanoferrate, there's a match. We've just confirmed iron 3. I'll give you a moment to jot this down in your data table. Okay, you have completed all 7 tests, and here's what your data table looks like. You have your 7 preliminary tests, you have your confirmatory test. There is one more test that you have to do or check, and it's called the handbook check. What you will do is take the handbook of chemistry and physics, these will be in the lab for you, and you open up to the inorganic compounds. And you'll have a close-up of this and what this looks like, and the information will be listed. It's alphabetically listed. We think we have iron 3 nitrate, so you go under iron. And once you look under iron, you go alphabetically, find the nitrate, and you read across the information. Now, as you look at your data table that you have in front of you, you have a place for the name, the chemical name. You have the formula, the color, the melting point and boiling points, and also you'll put in the date that you turn this in, and then you turn this in to me. And what I will then do is go ahead and check this to see the correctness of your identification. If you have them all correct, you have 50 points. If you happen to miss one of the unknowns, one of the either positive or negative ion, you get a 10-point penalty on that. So make sure make your observations clear and they're accurate, and doing the test correctly to make your identifications done. So that's all you need to do qual analysis. Be safe and have fun.